All right, we're going to start our power focus area 5, fields, forces, and energy, objective 1, mainly focusing on what is a force and what are the difference between contact and non-contact forces. So let's jump right into it. The definition of a force is simply a push or a pull on an object. So anytime there's a push or a pull on the object, whether things are touching or not, if I drop something out of the air, gravity pulls it to the ground, so there's a pull even though they're not touching, or like the guy in the picture at the top touching a box as he's pushing it, or the guy at the bottom pulling on a rope. A force is simply a push or a pull on an object. And these forces, whether they're pushes or pulls, can change an object's motion. They can make it move. They can make it move faster, slower, change its direction. Anything that changes its motion would count as a force from a push or a pull. If you're taking notes on the note guide in the summit, make sure you have it filled out. You can pause it on these slides. I'll just leave them up for a few seconds before we go to the next. So there's two main categories of forces, contact and non-contact. And you probably know what a contact force is, or can kind of figure it out. If you've ever heard of or played a contact sport, that means there's touching. Like in football, big time is a contact sport. Wrestling, you're constantly coming in contact or touching someone else. So a contact force is a force between two objects that are touching. So if the objects are touching, like the guy in the slide before that was pushing a box, they were touching, so that was a contact force. And here's some common examples. I mean, for the most part, when you think of a force, you're thinking of a contact force. A collision in that top picture on the left. Two cars there are colliding. Well, they're touching, so it's a contact force. This kid here is pulling the wagon. Tension means when a rope gets pulled, it gets tighter. Tension in a rope, and the little girl pushing her sister in the fire truck at the bottom. All are examples of contact forces because the objects are touching that are being pushed or pulled. So again, make sure you put in your notes what's highlighted. So one, we're going to go into particular because it's kind of tricky. We're going to talk about friction as a contact force. Friction is a force that acts between any objects that are touching, and it usually always causes some thermal energy to be formed. And what happens is friction, when your foot touches the ground or your wheel touches the ground, you're like on a tire, friction grips the tire and tries to stop it. Now, there's enough force usually in your foot or your car to overcome that force of friction, but it acts in the opposite direction that you move. If you notice in the picture, the wheel is rotating on our screen to the right. So friction is trying to stop it in that direction, and it creates enough of a kind of a grip to propel the car forward or your foot forward if you're walking. It might be easier to think of when there isn't much friction, like ice. It's hard to grip the road or for your foot to grip the ground, and it's harder to walk forward or drive forward because the friction has been reduced. So again, friction is a force between all objects that are touching. It's trying to stop motion, and the tires being able to move forward because of friction, or your feet move forward on the ground, are examples of how it works. Make sure you fill in your notes again. So if a contact force are forces between objects that are touching, non-contact forces are, yeah, you guessed it, forces between objects that are not touching. So it's still a force, so it's a push or a pull, but the objects are not touching. So gravity is a big example. I lift a pen in the air, you can see it on the little screen here. It's not touching the ground, but when I let go, it's pulled or attracted to the ground. So gravity would be a great example of a non-contact force. Another would be the electric or electrostatic force. Think about when you rub your socks on a carpet and you get near something metal or even another person. You're not touching them, but you get shocked because, well, it's a non-contact force. And if you look at the bottom of the slide here, it says opposite charges attract. So that means a positive and a negative charge will come together. Similar charges, like in the picture of the balloons, two negatives or two positives will push apart. I mentioned it earlier, gravity is a huge non-contact force. Look at the picture there. The moon is pulled around the Earth. The gravitational pull or force of the Earth is able to pull on the moon even though they don't touch, so non-contact force. Two factors affect how strong the gravity of an object is, because every object in the universe has a gravitational attraction to every other object. You just don't notice most of them, because the two factors are the more mass an object has, the more gravitational pull it has, and the closer two objects are, the more gravitational pull or attraction they have. So, yes, the moon is, you are attracted to the moon's gravity. You just don't feel it because it's farther away and it's smaller than the Earth. The Earth is gigantic, you're right on it, so you feel the gravitational pull of the Earth more. The sun has much more gravitational pull than the Earth, but you're not pulled off of the Earth toward the sun because you're so close to the Earth. So again, the size in terms of mass of an object and how close you are to an object determines how strong its gravity is. Make sure you fill in on your notes. A third big example of non-contact force are magnetic forces. If you've ever played with a magnet, they have a north and south pole, and those opposite poles attract. So if you put the north by the south on a desk and let go of them, they get pulled together magically, it appears, but not really. It's just a non-contact force, that magnetic force. And if you try to push two souths or two norths together, they push apart. You can't do it. They will push apart no matter what you do. And if you push them as close as you can and then let go, it'll actually flip around because it's pushed or repelled apart so much. So just like charges are repelled or pushed apart and opposite attract, the same with magnetic poles. Opposites attract, north and south, and the same push apart or repel. Make sure you're able to do all these things. These are all going to be potential types of questions. So I would just look over these, except number 3. I forgot to get rid of that here. We're not going to do that this year. But make sure you're able to do number 1, 2, and 4. Try it on your own. Practice. If you're not sure, shoot me an email and ask if you were right. And that is the first objective.